Imagine launching a spacecraft into the vastness of space nearly half a century ago, with the hope that it might survive a few years of exploration, and then watching it defy all odds by continuing to journey far beyond our solar system, sending invaluable data back to Earth decades later. This is the extraordinary reality of NASA's Voyager 1 spacecraft, currently the most distant human-made object in existence. It has crossed the boundary into interstellar space, a region far beyond the influence of our sun's solar wind and magnetic field. What makes this feat even more remarkable is that Voyager 1 continues to communicate with Earth, using technology that is older than cassette players, relying on computers with memory measured in mere kilobytes, and using a transmitter powered by roughly the same energy as a household light bulb. Despite these limitations, it still manages to relay precious scientific information from billions of miles away. Launched in 1977, Voyager 1 has recently made a discovery that is sending ripples through the scientific community worldwide. This finding is stirring excitement and curiosity because it opens up new possibilities about the nature of our universe and the environment that exists in the vast emptiness beyond our solar system. This incredible milestone invites us to reconsider many of our assumptions about space and what lies ahead as humanity ventures further into the cosmic ocean. The origins of this groundbreaking mission trace back to a brilliant insight by Gary Flandro, a scientist at NASA's Jet Propulsion Laboratory. In the early 1970s, Flandro identified a rare and fortuitous alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, that occurs only once every 176 years. This cosmic arrangement would allow spacecraft to use the gravity of each planet to slingshot themselves onward, gaining speed and reducing travel time dramatically. Using nothing more than pencil, paper, and the engineering tools of his time, Flandro mapped out a trajectory that would let the spacecraft reach all four gas giants on one mission. This gravity assist maneuver would shorten a trip to Neptune from an estimated 30 years down to just 12 years, a discovery that changed the entire landscape of space exploration. Faced with this rare celestial opportunity, NASA moved swiftly and decisively. In the summer of 1977, just 15 days apart, two identical spacecraft, Voyager 1 and Voyager 2, were launched. Their goal was to take full advantage of the planetary alignment, embarking on what was expected to be a 4-year mission to explore the outer planets. Few could have predicted that these two robotic explorers would not only survive the harsh conditions of space for decades, but would also rewrite history as the most enduring and farthest-traveling human-made machines. Today, over 45 years since their launch, Voyager 1 and Voyager 2 continue to function, operating in the extreme environment at the very edges of our solar system. They provide a continuous stream of data that offers insights into regions of space that were previously inaccessible. Their initial encounters provided humanity with the first close-up images and scientific observations of Jupiter's and Saturn's moons. These images revealed that these distant worlds are far more dynamic than anyone had imagined, showing volcanic activity on Io and massive ice fields on Europa and Enceladus, changing our understanding of the potential for life and geological activity beyond Earth. Voyager 2 made history by becoming the first spacecraft to visit Uranus in 1986 and Neptune in 1989. These flybys unveiled details about the atmospheres, magnetic fields, and moons of these planets, vastly enriching our knowledge of the outer solar system. The probe discovered active weather patterns, unusual magnetic orientations, and moons with surprising geological features, all of which challenged long-standing scientific assumptions. What makes these achievements even more impressive is that both Voyagers were about the size of a Volkswagen Beetle, yet they have exceeded all expectations in terms of endurance and scientific contribution. The journey itself was perilous. The spacecraft began with a gravity assist from Venus, a maneuver never before attempted for a mission heading toward Mercury and beyond. This helped build the velocity needed to travel the vast distances ahead. Then they had to navigate the asteroid belt, a hazardous zone filled with rocky debris. This was a challenge that had been overcome only recently by the Pioneer 10 and 11 missions. But the Voyagers were equipped with more advanced instruments and a sturdy design that allowed them to survive and thrive. Despite the remarkable journey, the technology aboard these probes is astonishingly limited by today's standards. Their onboard computers have just 69 kilobytes of memory, an amount so small it's hard to compare to the gigabytes found in even a simple smartphone. Data collected from their scientific instruments is stored on magnetic tape recorders, then transmitted to Earth via a low-powered transmitter. They use a 12-foot diameter antenna to communicate, sending signals at the speed of light across billions of kilometers. But as the spacecraft move farther away, communication delays have grown longer. Messages now take more than 18 hours to travel from Voyager 2 to Earth. Increasing background noise from radios, televisions, and cell phones on Earth has also made it harder for scientists to pick up these faint signals. Yet the team continues to receive valuable data. One of the most significant milestones for the Voyagers was crossing the heliopause, the boundary that marks the edge of the Sun's influence and the beginning of interstellar space. This boundary, estimated to be around 50 astronomical units from Earth, separates the solar wind, charged particles streaming outward from the Sun, from the cold, sparse plasma of the interstellar medium. When Voyager 1 crossed this boundary in August 2012, it confirmed an increase in plasma density, consistent with entering a new environment. However, contrary to expectations, there was no significant change in the magnetic field's orientation. Scientists had predicted a marked shift, as the spacecraft moved from a region dominated by the Sun's magnetic influence to one shaped by the magnetic fields of nearby stars. This unexpected finding has prompted researchers to reconsider how the boundary of our solar system interacts with the galaxy around it. As the Voyagers continue their journey through the mysterious interstellar medium, they slowly approach the distant Oort cloud, a vast shell of comet-like objects thought to surround our solar system at extreme distances, possibly extending halfway to the nearest stars. It will take thousands of years for the spacecraft to pass through this region, but their current data are already reshaping our understanding of the solar system's outer limits. The Voyager missions, with their humble beginnings and technological constraints, demonstrate the power of human curiosity, ingenuity, and perseverance. Their ongoing voyage is not just a story of machines in space. It's a testament to our desire to explore, to understand, and to push beyond the known boundaries of our world. These twin spacecraft, silently traversing the cosmic void, continue to inspire us, reminding us that even with limited tools, the quest for knowledge can reach across billions of miles and decades of time, revealing the secrets of the universe, one signal at a time.